All right, so we're going to talk about factorials. So on your graphing calculator, there is, depends on what calculator you have, but there may be a button that says X with an exclamation point or N with an exclamation point. If you don't see that button on the face of your calculator, you're going to go and look for a button that says math. And on the math screen, you're going to scroll over, once you hit math, up at the top, you're going to scroll over to PRB. And under there, under option 4, you should see, oopsie, that symbol, the factorial symbol, okay? It's called a factorial. And the way it works, for example, is for 5 factorial, what you do is you count backwards. Say 5, 4, 3, 2, 1. You stop at 1 because you're going to multiply all these numbers together. And if you don't stop at 1 and you go to 0 and you multiply them all together, you get 0. So 5 factorial. It's 5, 4, 3, 2, 1. Multiply them all together and you get 120. That is 5 factorial. Obviously, you can check it by multiplying it out the long way, or just hit 5, math, scroll over to PRB, option number 4, and put the factorial sign. Same thing here, 3 factorial, 3, 2, 1, 6 factorial, 2 factorial, 1 factorial. 1 factorial is 1 factorial. One thing to note, 0 factorial, it is 1. We do this because it makes the equations work better. So, how do I show what a factorial is using notation? So, this is the official notation in factorial. Let's explain it using our 5 factorial, okay? So what was I supposed to do? I was supposed to count backwards, starting at that number. So n factorial is n times, now I was supposed to subtract 1, right? So that would be 4. Well, that's n minus 1, right? 5 minus 1 is 4. And then I was supposed to say, well, 3. Well, that's 5 minus 2. And then 2. And then 1, right? So it's all the way down until 1. So in notation, this is how a factorial works. N cannot be a decimal, and it cannot be a fraction, a radical, or a negative number. Basically, it's got to be a whole number, okay? We define, like I said, 0 factorial to be 1, because if not, our formulas won't work. It says, yes, you have a button on your calculator, but you need to get comfortable without the calculator because, for example, numbers like this, 70 factorial. If you put it in your calculator, you might get an error. Maybe not. Maybe you got an answer. But if you try 450 factorial, that definitely gave you an error. And the reason is because the number is so large, right? You probably got number, and then e to the something, right? And that's because, and maybe you got that with this one. This one's going to give you an error, and basically it's because it's too big and the calculator can't spit it out. So, how can I do this without a calculator? So, let's start easy. 8 factorial divided by 5 factorial. And please know, it is not 3 factorial. What are you going to do? Well, you know what 8 factorial is. It's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? And you know what 5 factorial is. It's 5, 4, 3, 2, 1, right? Multiply together. So take a look. If we write it out, remember fractions cancel top and bottom, so I can take 5, 4, 3, 2, 1 and cancel with 5, 4, 3, 2, 1. So really, 8 factorial divided by 5 factorial, it's just 8 times 7 times 6, which is 336. Obviously, you can use your calculator for 8 factorial divided by 5 factorial, but if we get something like, I don't know, something larger, that won't work in your calculator. This is where we need to know how to do this. Let's try this with 6 factorial divided by 4 factorial. 4, 3, 2, and 1, and 4, 3, 2, and that's supposed to be a 1. And again, you'll notice 4, 3, 2, 1, 4, 3, 2, 1. One other thing that you might have noticed is that I could have stopped 6 times 5 times 4 factorial. 4 factorial. Because isn't 4 factorial 4, 3, 2, 1? And isn't the bottom 4, 3, 2, 1? And couldn't I have canceled it like that? to just get 6 times 5, which would get you 30. So that's another way of thinking about it. What about this one, right? 73 factorial and 70 over 70 factorial. I don't want to write them all out. What I want to do is I want to use that trick that we just talked about. So this right here just explains the trick, right? Instead of writing all of this 5 all the way down and 5 all the way down, we notice that, well, 5, 4, 3, 2, 1 is 5 factorial. And so we could cancel and we got the answer. So for this one, this larger one, 73 factorial over 70, what are we going to do? Just do 73, 72, 71, 70. Stop when the bottom number. So then all I have to do, oh, well, those just cancel out. Oh, so it's just 73 times 72 times 71. Makes it a lot easier, a lot faster. How about this one? 5 factorial over 2 factorial over 3 factorial. Let's think about it. I've got 5, 4, 3, 2, 1 over 2 times 1 times 3 times 2 times 1. Right? Because this one is the 2 factorial and this one is the 3 factorial. Now, when we are trying to cancel things, we usually try to cancel the one that's the largest. So for me, I'm going to cancel the 3 factorial. So 3, 2, 1, 3, 2, 1. Again, we could do that trick. That's 3 factorial, 3 factorial. So we can cancel. Here it is kind of written out for you. 2 factorial, 2 times 1, 3, 2, 1. We cancel, and you see that we get the same thing. We get 20 over 2, which will give you 2, or 10. Again, this is a more efficient way. If we notice, right, pick the larger so that it, pick the larger so that you can cancel more values. Let's take a look at this one. 10 factorial over 2 factorial over, 10 factorial over 2 factorial, 8 factorial. I want to cancel that one. That's the largest one on the bottom. So I'm going to say 10 times 9 times 8 factorial. I'm going to stop. Now I'm going to go to the bottom and I'm going to say 2 factorial. Well, that's 2 times 1. And I'm just going to write 8 factorial because I'm going to do that. So I can get 90 or 10 times 9. And on the bottom I get 2, which will just give you 45.